Coffee begins its life far away from the hum of machines and stainless steel tanks. Long before it becomes instant granules inside a factory, it starts as a living crop, rooted in soil, shaped by climate, and nurtured by time. Understanding instant coffee means first understanding this journey from nature to science, from farm to factory, and from raw bean to rich liquid extraction. This is the foundation of everything that follows. The birthplace of coffee: tropical coffee farms. Coffee grows best in a narrow band of the world known as the coffee belt, stretching across regions near the equator. These areas offer the perfect balance of altitude, rainfall, shade, and temperature. Here, coffee plants grow slowly, allowing complex flavors to develop inside the beans. Coffee plants take several years to mature before they produce fruit. When they do, the fruit appears as small cherries that gradually turn from green to deep red. These ripe red cherries are the signal that the beans inside have reached peak flavor potential. Harvesting is a critical moment. In many regions, skilled workers selectively pick only ripe cherries by hand. This careful selection ensures consistency and prevents underdeveloped or overripe beans from entering the supply chain. In large plantations, mechanical harvesting may also be used, followed by sorting to remove imperfect cherries. Once harvested, time becomes the enemy. Coffee cherries must be processed quickly to prevent fermentation and spoilage. Processing coffee cherries into green beans. At processing stations near the farms, the outer layers of the coffee cherry are removed. First, cherries are washed to eliminate dirt and debris. Then they pass through pulping machines that strip away the red skin, revealing the beans inside. These beans are still covered by a sticky layer called mucilage. To remove it, the beans are either fermented in water tanks or mechanically washed, depending on the desired flavor profile. Fermentation is closely monitored, as even a few extra hours can dramatically change the taste. After washing, the beans are dried, either under the sun or in controlled drying facilities, until they reach a precise moisture level. Too much moisture leads to mold, too little damages flavor. This balance is carefully maintained. At this stage, the beans are known as green coffee beans. They are stable, shelf-ready, and packed into large sacks for global transport. Global transportation to the factory. Green coffee beans now begin their international journey. They are loaded into shipping containers and transported across oceans by cargo ships, trucks, and trains. Throughout this journey, conditions such as humidity and temperature are monitored to protect quality. When the beans finally arrive at a modern instant coffee facility, such as those supplying Nescafé, their transformation truly begins. Arrival and advanced quality inspection. Before a single bean is roasted, quality control takes over. Incoming beans are sampled and tested for moisture content, size, density, and defects. Advanced optical scanners and sensors analyze thousands of beans per second, rejecting any that are broken, discolored, or contaminated. This stage ensures that only beans meeting strict standards move forward. Consistency is everything. Instant coffee must taste the same whether it's consumed today or 6 months from now in any country. Once approved, the beans are transferred into massive climate-controlled storage silos. These silos protect the beans from humidity, pests, and oxygen while maintaining freshness until roasting begins. Precision roasting, where flavor is born. Roasting is one of the most crucial stages in coffee production. Green beans are chemically stable but flavorless. It is only through roasting that coffee develops its signature aroma, color, and taste. Inside industrial roasters, beans are heated at precisely controlled temperatures. As they rotate, internal chemical reactions, such as the Maillard reaction, begin to occur. Sugars caramelize, acids evolve, and aromatic compounds are released. Every variable matters. Temperature, time, airflow, batch size. Light roasts preserve acidity and subtle notes. Dark roasts emphasize bitterness and boldness. For instant coffee, roasting profiles are carefully selected to ensure balance, solubility, and mass appeal. Sensors and computer systems continuously monitor the process, making micro-adjustments in real time. Once the desired roast level is reached, the beans are rapidly cooled with air to stop the roasting process instantly. This locks in flavor and prevents burning. Grinding, preparing for extraction. Roasted beans are now brittle, aromatic, and ready for grinding. Industrial grinders break the beans into uniform particles, not too fine and not too coarse. This consistency is essential because it directly affects extraction efficiency. If the grind is uneven, some particles over-extract while others under-extract, leading to bitterness or weak flavor. Unlike home coffee grinding, this step is optimized for industrial brewing. Particle size is selected to maximize flavor yield while allowing efficient water flow in large extraction systems. Once ground, the coffee moves immediately to the brewing stage to preserve aroma. Industrial brewing on a massive scale. Now comes the stage that most closely resembles the coffee you make at home, just on an extraordinary scale. Ground coffee is loaded into large extraction vessels, where hot water flows through the grounds under controlled pressure and temperature. This process dissolves soluble compounds, oils, and aromatic elements from the coffee. The goal is to extract as much desirable flavor as possible without pulling excessive bitterness. Engineers carefully control water temperature, contact time, pressure. The result is a dark, aromatic liquid coffee concentrate, essentially brewed coffee, but far stronger than what is consumed in a cup. At this point, the coffee already smells rich and inviting, but it still contains a large amount of water and volatile aromas that must be preserved. Concentration: removing excess water gently. To prepare the coffee for drying, excess water must be removed without damaging flavor. This is done using vacuum evaporation systems. By lowering air pressure, water can evaporate at lower temperatures. This gentle process protects sensitive flavor compounds that would otherwise be destroyed by heat. As water is removed, the coffee becomes thicker and more concentrated. This step reduces energy consumption in later drying stages and improves final quality. Aroma recovery: protecting coffee's soul. One of the biggest challenges in instant coffee production is aroma loss. Coffee aromas are volatile and easily destroyed during heat processing. To solve this, modern factories use aroma recovery systems. Vapors released during brewing and evaporation are captured, cooled, and stored separately. These aromas, often described as the soul of the coffee, are preserved for later reintroduction. Without this step, instant coffee would lack the inviting smell people expect when opening a jar or pouring hot water into a cup. The foundation is complete. At the end of this stage, coffee has traveled an incredible distance, both physically and chemically. It began as a fruit growing under the sun. It passed through human hands and high-tech machines. It was roasted, ground, brewed, concentrated, and refined. What remains is a powerful liquid essence of coffee, packed with flavor and aroma. This liquid is the foundation for everything that follows: the drying, granulation, blending, and packaging that transform it into instant coffee. But none of that would be possible without this first journey. From coffee farms to industrial brewing, this is where instant coffee is truly born. What makes instant coffee truly remarkable is the moment when liquid coffee, freshly brewed, aromatic, and complex, is transformed into dry granules that can travel the world and dissolve instantly in hot water. This stage is where modern food science, engineering, and precision manufacturing come together to create a product defined by convenience, consistency, and global familiarity. It is also the stage that most clearly separates instant coffee from all other forms of coffee. Once the coffee extract has been brewed, concentrated, and stabilized, it enters the most critical phase of instant coffee production: drying. At this point, the coffee still contains a large amount of water. Removing this water is essential, but it must be done carefully. Too much heat can destroy flavor compounds. Too little control can lead to poor solubility or dull taste. The challenge is not just drying coffee, but drying it in a way that preserves its character. Modern factories typically rely on two primary technologies for this transformation: spray drying and freeze drying. Each method serves a different purpose, and both are used strategically to meet quality, cost, and flavor goals. In spray drying, the concentrated coffee extract is pumped to the top of a tall drying tower. Inside this tower, the liquid coffee is sprayed through fine nozzles, breaking it into microscopic droplets. At the same time, hot air flows through the chamber. As these tiny droplets fall through the hot air, the water inside them evaporates almost instantly. What remains are fine particles of dried coffee that collect at the bottom of the tower. This process happens in a matter of seconds, yet it requires extremely precise control. Air temperature, droplet size, airflow speed, and humidity are all carefully monitored. If the droplets are too large, they may not dry completely. If the air is too hot, flavors can degrade. Engineers constantly fine-tune these parameters to ensure uniform drying and consistent quality. Spray drying is efficient and well-suited for large-scale production. It produces a fine powder or small granules that dissolve quickly in water. This method is widely used for many instant coffee products because it balances speed, energy efficiency, and reliable results. For premium instant coffee, a different method is often used: freeze drying. This process is slower, more energy-intensive, and more expensive, but it delivers superior aroma and texture. In freeze drying, the concentrated coffee extract is first frozen at extremely low temperatures. This creates solid sheets or slabs of frozen coffee. These frozen pieces are then broken into smaller chunks and placed into a vacuum chamber. Inside this chamber, pressure is reduced to such a low level that ice does not melt into water. Instead, it changes directly from solid ice into vapor, a process known as sublimation. Because sublimation occurs at low temperatures, delicate aromatic compounds are preserved far better than in high heat drying methods. The result is larger, porous coffee granules with a light, airy structure. These granules not only look more premium but also release aroma more effectively when hot water is added. The texture of freeze-dried coffee is one of its defining features. The porous structure allows water to penetrate quickly, ensuring fast dissolution while maintaining a richer sensory experience. This is why freeze-dried instant coffee often has a stronger aroma and a more freshly brewed impression. Once drying is complete, whether by spray drying or freeze drying, the coffee is no longer a liquid. It has become a stable, shelf-ready solid. But the process is far from finished. At this stage, the dried coffee particles are carefully collected and transferred to blending systems. Blending is one of the most underestimated yet most important steps in instant coffee production. Unlike single-origin specialty coffee, instant coffee is designed to taste the same every time, everywhere in the world. Achieving this level of consistency requires careful formulation. Different batches of dried coffee may have slightly different characteristics due to natural variation in beans, harvest seasons, or processing conditions. Blending allows producers to balance these differences. By combining multiple batches in precise ratios, they can create a final product with a stable flavor profile. This process is guided not only by machines but also by human expertise. Professional tasters and sensory analysts regularly evaluate coffee samples. They assess aroma, bitterness, acidity, body, and aftertaste. If a batch lacks strength, it can be balanced with a stronger one. If bitterness is too pronounced, it can be softened through blending. During blending, previously captured coffee aromas are often reintroduced. These aromas were collected earlier during brewing and concentration, when volatile compounds were at risk of being lost. Reintroducing them at this stage dramatically improves the sensory impact of the final product. When a consumer opens a jar of instant coffee or pours hot water into a cup, that familiar coffee smell is not accidental, it is carefully engineered. Once blending is complete, the instant coffee moves to the packaging stage. Packaging is not simply about filling jars or sachets. It is a critical step in preserving quality over time. Instant coffee is highly sensitive to moisture, oxygen, and light. Exposure to any of these elements can cause clumping, flavor loss, or staleness. To prevent this, packaging lines operate in controlled environments. Humidity levels are kept low, and oxygen exposure is minimized. Automated filling machines measure exact coffee with high precision. Whether the product is destined for glass jars, metal tins, refill packs, or single-serve sachets, each unit must contain the correct amount. Even small variations are unacceptable at industrial scale. After filling, containers are sealed immediately. In many cases, inert gases such as nitrogen are used to displace oxygen inside the package. This creates a protective atmosphere that slows oxidation and extends shelf life. Lids are secured, seals are checked, and labels are applied at high speed. Every package is marked with batch numbers and production codes. This allows full traceability, meaning the factory can track exactly when and where each product was made, down to the specific production line and time of day. Quality control continues even after packaging. Samples are randomly selected from production batches and sent to laboratories. Their technicians test solubility, moisture content, aroma release, and taste. Coffee is dissolved in hot water to ensure it dissolves completely without residue. Aroma is evaluated both dry and after brewing. Shelf life tests simulate long-term storage under different conditions. Only after passing all quality checks is the product approved for distribution. From here, instant coffee enters a global logistics network. Pallets of finished products are wrapped, labeled, and loaded onto trucks. They move to distribution centers, ports, and warehouses, eventually reaching supermarkets, small shops, offices, hotels, and homes across dozens of countries. What makes this achievement remarkable is not just scale, but consistency. A jar of instant coffee purchased today should taste the same as one purchased months later, even if it was produced on a different continent. Brands like Nescafé have built their reputation on this reliability. Achieving it requires strict control at every stage, From drying technology to blending formulas to packaging integrity, the journey ends where it began for the consumer in a cup. A spoonful of granules meets hot water. Within seconds, the granules dissolve, releasing color, aroma, and flavor. There is no brewing equipment, no waiting, no waste, just instant coffee, ready to drink. Behind that simplicity lies an extraordinary chain of science and engineering. Liquid coffee was frozen, sprayed, dried, blended, protected, tested, and transported, all so that the final experience could feel effortless. This transformation, from liquid extract to instant granules and finally to a global consumer product, is the defining heart of instant coffee production. It is where modern technology turns a complex agricultural product into something accessible to millions of people every single day.